Hi, this is Ahmed Al-Qutub, Project and Risk Management Consultant, and we are still in the Project Management Professional Training videos. Today we're going to learn one of the important tools that every project manager has to know that will help him to develop his project schedule. Why? Because the schedule is considered to be one of the project baselines. We have three baselines in every project: scope baseline, schedule baseline, and the cost baseline. And for the project manager, has to know the tools that will help him to develop these baselines. Why? Because these baselines are used later on in order to measure the performance of the project. So when we have a actual performance of the project, it has to be measured and compared to the baselines. If they are equal to the baselines, then the project is under control. If they are not, then the project is out of control, and the project manager has to take certain actions in order to put the project back into the track. So what's the tool that will help us to develop our project schedule? That tool is called the Project Schedule Network Diagram. That's going to be the document, the project document that will be developed throughout the tool that we're going to learn today, and it will help the project manager how to develop his project schedule later on. And at the end of the video, I have a tip for those who are attending the Project Management Professional Certificate about the network diagram and how they can tackle it into their exam. So let's go to the outlines. What is our outline for today? The first topic we're going to cover is develop the network diagram, determine the critical path, and that will be the path forward, and determining the free float, and that's going to be the path backward. Before we go further in developing the network diagram, we need to understand the following terminology, which is the activities dependency. Why? Because there are certain activities within our project, they have a dependency on each other. It means that one activity will never happen unless the other activity is happening before. And in this case, we have two types of dependencies. One of them is called mandatory dependency, and that's a hard logic. This is the only way we can do the business with. Or discretionary, or we call this the soft logic. It means this is how we prefer to do the work in this sequence. And some activities, they don't have any dependencies between each other, and they are considered to be parallel activities, and they are presented in a parallel pattern as you see. Now, the dependencies, the activities that they have dependencies, they are presented in a sequential manner. Why? Because the first activity to come is called the predecessor, and it has to be completed before the activity to follow, which is called the successor, is to start. And we call this a mandatory dependency, or a soft logic dependency, or discretionary dependency. But in general, these two activities, the predecessor and successor, they have a dependency between each other. That's why they have to be visually presented in our network diagram as a sequential activities. If there's no dependency between these activities, then they will be considered to be a parallel activities, and we'll demonstrate that in when we start drawing our network diagram. You will see that some activities are considered to be sequential and some of them are considered to be parallel. Why? Simply because they don't have any dependency between each other, and that's why they are parallel, or they have a dependency, that's why they are sequential. Let's see what happens in the real world. As an example, I'll be selecting from the WBS, the work breakdown structure, one of the deliverables, and it's 2.1.3.1 slab construction. And I will decompose that deliverable into the following activities: construct steel structure, shattering, pour the concrete, and remove steel structure, which is the shattering. I will keep it short for elaboration intentions, just three activities. And these three activities are decomposed from the deliverable that I have selected from the work breakdown structure. If we would like to start visually presenting our activities, we will find that the activity shatter is to come first before pouring the concrete, or the shattering. Why? We call this a mandatory or hard logic dependency. We cannot do it the other way. Shattering has to be the first activity in order to complete the scope. In this case, we call shattering the predecessor. So this is predecessor number one. Then pouring concrete is the successor of the shattering. In this case, we will have a successor number one. If you would like to further complete the sequence of the three activities, then the activity that will come after or follow the pouring concrete is the shattering, and in this case we will have a predecessor to, which is pouring the concrete, will be the predecessor of the successor number 2, which is the shattering. Why we are presenting these activities in this matter? Because the 3 activities, they have a dependency on each other. The shattering to start is dependent on completing the concrete, and pouring the concrete to start is depending on the shattering to be completed. How the network diagram look like? In order to be able to draw the network diagram, we need to start the network diagram with a black diamond, which is representing a milestone, and that milestone is the start. And it will end with another black diamond, which is considered to be another milestone, which is considered to be the end of the activities. Now, milestones are supposed to be distributed all over the project, but we have 2 fixed milestones, which is the start and the end. And in the network diagram, we will have the start and the end presented in the network diagram as a start, as an end, and you will see that activity or the milestone start has no predecessors. And the activity E, the milestone E, has no successors. Why? Because the start is the first thing to happen in the project, and the end is the last thing to happen in the project. Therefore, start has no predecessors, and end has no successors. All the other activities that we have in the project in order to complete the deliverables or complete the project will be between the S and the E, between the start and the end, between these 2 diamonds, which is the start diamond, which is a milestone, and the end diamond, which is another milestone, and all the other activities will be sequenced within the network diagram. The tool that we have used in order to demonstrate or visually represent the sequence of the activities is called precedence diagramming method. In some books they call it father-child diagram, but let's stay with what PMI are telling us. They are telling us that this is called a precedence diagramming method, and it is a tool and a strategy for developing the project schedule network diagram. It's not to develop the schedule, it's one of the activities that I do in order to develop the schedule, and we call this project schedule network diagram. It utilizes the nuts, as you see, and it will be representing the activities, and it will be associated with the other elements in order to illustrate the dependencies between these activities within my project. So the tool that we are using is called precedence diagramming method, where we'll be presenting the activities in a node, and it will show the dependencies between these activities, and by completing all the activities we will have the project schedule network diagram. Let's take an example. For an example, I have prepared a table of 8 activities to a certain project or a certain deliverable, where we will see that on the left column we are presenting the activities, and for simplicity purpose I have used letters, but I can replace any of these activities with any activity statement, such like install the furniture, remove the lights. So any kind of activity statement can be replaced with these letters, but only for the intention to make things easy and simple, I'm going to use the letters. On the other hand, the right column, it's presenting the activities dependency, and it's enough for us to mention the preceding activities or activity in order to know the dependency and the relationship between the activities. If we look into this table, we'll find that the first activity is called the start, and we have mentioned in the previous slide that the start is a milestone and it's presented as a black diamond. Then activity D and activity A. Activity D has a predecessor as a start, and activity A has a predecessor start. So activity A and activity D are presented in the following pattern on the network diagram, and you will see that they have one predecessor, which is the start, and in this case a quick observation that activity A and D are parallel activities. Why? Because they are not depending on each other and they don't have any relationship, and in this case they will be visually presented as parallel activities. After activity A and D are presented, we look into the other following activity, which is activity F. The preceding activities of activity F is D and A. What does that mean? It means that activity F will never start unless activity D and A are completed. In this case, you will see that activity F, it has two predecessors. And usually the activities that they have more than one predecessor, we consider them to be risk potential, since they have more than one dependency conjunction. For the administration purposes, for the supervision purposes, and that's actually increased the chances of this activity to be late and cost more. Why? Because it's depending on more than two predecessors. So how it will be presented on our network diagram? It will be presented as a successor for activity A and activity D. The activity to follow is activity E. And if we look on the preceding activity, we will find that activity E has only one predecessor, which is activity D. And this is how it will be presented and look like on the network diagram. And again, a quick observation, we will find that activity F and E, they are parallel activities. They are not depending on each other. Likewise, you will understand that activity A and E are parallel activities. Again, why? Because there's no relationship between activity A and activity, or there's no dependency between activity A and activity F. So how it will be presented? It will be presented as a parallel activity to activity F, and it is and it will be the successor of the predecessor D. The activity to follow is activity G. And if we look into the preceding activity, we will find that G has two predecessors, which is activity F and activity E. Again, it's considered to be a risk potential activity. Why? Because it has more than one dependency conjunction. So how it will be presented? It will be presented as a successor for the two predecessors, which is F and E. What does that mean? It means that activity G, again, will never start until activity F and E are completed. In this case, we cannot say that activity G and activity A are parallel activities. Why? Because you see that activity F is a successor of activity A and F is a predecessor of activity G. So definitely there's a sequence between activity A and activity G, but it's not a direct sequence. Why? Because they have an activity in between, which is considered to be the predecessor of the later successor. But however, this is how it will be presented on our network diagram. G is the successor of the two predecessors F and E. Activity B is the next in our table, and it has only one preceding activity, which is activity F. Activity F is considered to be the predecessor of activity B, and this is how activity B is presented in our network diagram. And again, you will find that activity B and activity G are considered to be parallel activities because they don't have any dependency between each other. Activity H is the next to have in our table, and again it has only one preceding activity, which is activity G. So activity H will be presented in this way in our network diagram, where G is considered to be the predecessor and H is the successor. And again, we see that activity H is considered to be a parallel activity to activity B. They have no dependency between each other, and as far as we go, you will see that we will have more activities that they are parallel and more activities that they are to be sequenced. Because we are running out of space, I'm going to just reduce the table, and I'm going to keep just only the last two rows that I need to complete the network diagram. And now we are with activity C. Activity C, again, it has only one predecessor, and that predecessor is H, and this is how it's presented in our network diagram. And very obvious quick observation that activity G, H, and C are parallel activities to B, but G to H to C, they are considered to be sequential activities. Finally, we'll see that the last activity is the end, and end is a milestone, and it will be represented as a black diamond. And the preceding activities of the end are C and B. So we will complete the relationship between the dependency between B and C till the end, and this is how it will be presented on our network diagram. After completing all the activities, this is how my network diagram looks like. It is a visual representation of the activity sequence in my project. It will tell me which activities are having a dependency and which activities they don't have dependencies. And also, if you look into this network diagram, you will discover that we have different paths from start till end. The first path is from A, F, and B till the end. That's considered one path. And from activity A, F, G, H, C, end is another path. And we have the activity D, F, B till the end. That's a path. And D, F, G, H, C is another path till the end, and D, E, G, H, C is considered to be another path. And from this network diagram, we are able to know that I have 5 paths in order to complete the project from start till end. Last thing we need to do is to make sure that we don't have any open ends. What does it mean, open ends? It means that we are having an activities on our network diagram that they don't have any predecessor, or the activities that we have on our network diagram, they don't have any successors. And in this case, you need to ignore definitely the start and the end, because the start, it doesn't have any predecessor, and the activity or the milestone end, it doesn't have any successors. So let's look into the network diagram and see activity A, it has a predecessor, it has successor. D, it has a predecessor, successor, and so on. F, E, B, C, H, and C. Yeah, everybody has every activity, it has a predecessor and it has a successor except the start and the end. And in this case, I'm sure that my network diagram doesn't have any loose ends, or it doesn't have any open ends. Actually, the activity node on the network diagram looks like this. We have it split into different parts, where on the top left we will have the ES, which is the early start. In the next corner, top next corner, we will have the EF, which is the early finish. In the bottom left, we will have the late start, and the other corner bottom, we have the late finish. And in between, we have the slack or the float. They are the same. And we have the activity and its duration. There is an equation over here that we use in order to complete this node, which is early start plus the duration will give me the early finish. And if we are using some math over here, we will have a reversed equation from this, and it will be the early finish minus the duration will equal the early start. And the early finish minus the early start will give me the calculation, and that's just a simple math. If you remember one of these equations, the other equations are just reversible equations, so you don't need to remember them. It's enough to remember just one equation, which is that the early start plus the duration will give me the early finish. The same for the formula to calculate the late start, late finish throughout the duration. The original formula is late start plus the duration will equal to the late finish. And if you look into the reverse equations, late finish minus duration will equal late start, and late finish minus the late start will equal duration. And again, if you remember one of these equations will be enough to know the other equations, because they are just a simple math of reversed equations. Before we go further, let's make things more practical. In front of you, there's a table that has 13 activities without the start and the end for sure. And there are precedencing activities as well. Ignore for the time being the time estimation. We're going to use it later on once we start building up the path forward and the path backward. So for the time being, I want you to start drawing your network diagram. You can pause the video right now and start drawing your network diagram, and when you come back, we will continue. This is how your network diagram should look like. If it doesn't look like this, check, compare, and see where you have done the mistake. Now, let's continue with the other subjects that we have in developing the network diagram, and we're going to talk about the path forward planning. Now let's draw activity D in the node. How early we can start activity D? The earliest we can start activity D is 0. Why? Because this is the first activity after the start, and it has only one predecessor, which is the start, and there's no duration, because the milestones usually they are 0 duration and 0 cost. So the earliest I can start activity D is on 0 time. And the duration of the activity D is 4 months. If we use the equation, early start plus the duration will equal the early finish. Then the duration of activity D is 4 months, and we can start it as early as 0. 0 plus 4, that will equal 4. Then the earliest finishing time for activity D is 4. Now let's do the same for activity A. Activity A has the predecessor of start as well, and it's a milestone, and it has a 0 duration. So how early I can start activity A? I can early start it as a 0 duration, and the activity duration is 3 months. We use again the equation early start plus duration, it will equal early finish. So the early start is 0 and the duration of the activity is 3 months, so my early finish will be 3. This is how the two activities will look like in the network diagram after we draw the two nodes. A and D, they are parallel activities, and they have as early as a start as 0, and activity A has early finish 3, and activity D has an early finish of 4. Now let's do activity F. This is the next that we have in the table, and activity F, it has two predecessors, the D and the A. Since activity F has two predecessors, it means that this activity, which is F, cannot start unless activity D and A are completed. If we look into activity A, we find that the early finish of activity A is 3, while the early finish of activity D is 4. So F to start, both activities are supposed to be completed. Then activity D, the one that has the highest early finish, is the one that will be selected. So we're going to take it as a rule, whenever we have two predecessors for an activity, we're going to select the highest value of early finish of the predecessors. Simple math again, we use the same equation, which is E, which early finish, early start plus the duration will give me the early finish of the activity. So how early I can start activity F? I will finish it as early, I'll early start it as 4, because this is the early finish of activity D. Then 4 plus 8, and that's the duration of activity F, and the value will be 12 months for early finish for activity F. Activity E is the next on our table, and you will see that activity E has only one predecessor, which is activity D. So how early I can start activity E? I can early start it as early finish of activity D, and that will be 4. So we use 4 to be the early start of activity E, and simple math again, early start plus the duration. Since the duration of activity E is 9, then it will be 4 plus 9, and that will be 13. So how early I can start activity E? It will be as early as 4, since the early finish of activity D is 4, and the how early I can finish activity E, it will be as early as 13. The activity to follow is activity G, and here G, it has two predecessors, and again we said let's take it as a rule. If we have an activity that has two predecessors or more, we have to look into the early finish of all these activities, and we need to select the longest early finish of the predecessors, and that's going to be the early start of the successor. We have here activity F and E are the predecessors of G. F has an early finish of 12, and activity E has an early finish of 13, and definitely 13 is greater than 12. So the early finish of activity E will be the early start of activity G. Why? Because this is the greatest or longest early to finish from the two predecessors. Again, G will never start unless the activity F and E are completed, and it is the longest one, which is the 13. And I would like just to remind you one more time that the activities that have multiple predecessors are considered to be risk potential activities. Again, we're going to use the same equation, which is the early start plus the duration will equal the early finish of an activity. And since we are using the 13 as an early start plus the duration of 4 months, and that will be 13 plus 4, and that will be 17. So how early I can finish activity G is 17. How early I can start it? I can start it as a 13. Activity B is the next on the table, and we'll see that activity B, it has only one predecessor, which is activity F, and the duration of activity B is 4. So the early finish of activity F is 12, and that's going to be the early start of activity B. So 12 plus the duration 4, and that's going to be 16 months. Again, we have used the same equation. The early start plus the duration will give me the early finish of the activity. Again, in order to have enough space, I'm just going to reduce the table to the remaining activities. And next to come is activity H. Activity H, it has only one predecessor, which is activity G, and the duration of the activity is 12. What is the early finish of the predecessor G? The early finish of the predecessor G is 17, and that's going to be the early start of activity H, which is the successor. Adding to the 17 the duration of 2 months, and that's going to be 19 months as an early finish of activity H. How early we can start activity H? It's 17. How early we can finish it? It's 19. The last activity in my schedule is the activity C, and it has only one predecessor, which is activity H. Therefore, the early start of activity C should be the early finish of the predecessor. The predecessor is 19, and the duration is 7. It's 19 plus 7, and that's going to be 26 months. Again, back to the same equation. Early start plus the duration will give me the early finish of the activity. Last thing we need to do is to complete to the milestone, which is the end, and we will see that we have only 2 preceding activities of the milestone end, which is activity C and B. And if you completed, now the network diagram is completed using the path forward method. If we look into the last 2 activities, which is activity B and activity C, we'll see that the early finish of activity B is 16, while the early finish of activity C is 26. What does it mean? It means that in order to complete all the activities within this network diagram from start till the end, I need 26 months. So the project duration is 26 months. Some might say, why we're not taking the 16, which is the early finish of activity B? What you need to do, just go back into the network diagram and let's see who are the predecessors of activity B. The predecessors of activity B, they are F and A and D. Therefore, if you would like to use the 16 months as a duration, you will only finish activity A, D, F, and B. The project duration from the network diagram is the longest duration you will find on the end activities. Just to make it easy and simple, when you finish your network diagram using the path forward method, look into the activities that they are the predecessors of the end, and check which activity has the longest duration, and that's going to be your project duration. Now we have to complete our network diagram and start filling the late start and late finishes, and we will use it for this purpose the path backward method, and we'll start from the end and we'll go towards the start, and that's going to be a backward method. The equation that we will use is that the late finish minus the duration will give me the late start. The first thing we need to do is to look into the activities that they are the predecessor of the end. And in our case, in this network diagram, we have only 2 predecessors, activity B and activity C. And in the late finish box, we will write for all the activities that they are predecessors of the end, the longest duration. And in our case, the longest duration is 26. So 26 is going to be the late finish of activity B, and 26 is going to be the late finish of activity C. We use the equation in order to complete the late start of activity B and the late start of activity C. 26, which is the longest or the late finish, minus the duration, which is 4, and we are doing the calculation for activity B. 26 minus 4, and that's going to be 22. So the late start of activity B will be 24. What about activity C? Activity C will have the late finish is 26 minus 7, which is the duration of activity C, and it will be 19 as a late start. Let's continue backward. You can start activity B or you can start activity H, but in our case you cannot go from B to F directly. Why? Because F, it has one successor, which is G, and G has a successor of H, and H has a successor of C. So it's better to complete whoever is having the multiple successors, and in order to do that, we'll start with activity H. Activity H has a duration of 2, and the late finish of the activity H will be the late start of the activity C, which is the successor. So when we are going backward, we're going to take the late start of the successor, and that's going to be the late finish of the predecessor, and in the H case it is 19. Again, we use the same equation, late finish minus duration, it will equal late start. 19 minus 2 as a duration, and that's going to be 17. What about activity G? Again, activity G has the successor of H, and the late start of activity H, the successor, is 17. So we're going to take this 17 and make it the late finish of activity G, which is the predecessor. Use the same equation, 17 minus 4, and that's going to be 13. And over here we can stop in order to complete either activity F or activity E. And I believe that we can go with activity F right now. Now, since F has two successors, activity B and activity G, in the forward method we said you select the highest early finish of the predecessors, and you will have it as the early start of the successor. When we are doing the backward method, since we have two successors over here for one predecessor, we're gonna select the shortest late to start from the predecessors, from the successors. Sorry, let's say that again. If I'm going in the backward and I have multiple successors, I'm gonna select the shortest or the lowest number between all the late to start between all the successors, and that's going to be the late finish of the predecessor. In our case here we have activity B, it has a late start of 22, and activity G, it has a late start of 13. We will select the lowest duration. We're going to select the lowest late start between these two activities. If I have 3, 4, 5, 6, whatever activities that I have, I'm going to select the lowest one. We decided that the lowest or the shortest late to start between the two successors that I have, B and G, is 13. So 13 will be the late finish of the predecessor F. So we're going to use again the equation, late finish minus duration, it will equal late start. 13, that's the late finish of activity F, and the duration is 5. The duration is 8 months, so 13 minus 8, and that will be 5. So 5 going to be the late start of activity F. Activity E. Activity E, it has only one successor, which is G, and the late start of activity G is 13. Therefore, the late finish of activity E will be 13 as well. and we do the same, we use the same equation. Late finish minus duration equal late start. 13 minus 9 months as a duration, and that's going to be as a 4 as late start for activity E. If we go to activity D, we see that activity D, it has two successors, and we use the same principle and the same rule. If we have multiple successors, we're going to select the lowest late start of these two successors. The two successes that we have for the activity D are F and E. F, it has a late start of 5, and activity E, it has late start of 4. The rule says that we have to select the lowest late to start between these two successors, and that's going to be the late finish of the predecessor D. So we're going to select 4. 4 is going to be the late finish of activity D. Use the same equation. 4 as a late finish minus 4 months as a duration, and that's going to be 0 as a late start. We still have only one activity, which is activity A, and it has only one successor, which is F. So the late start of activity F is 5, and that 5 is going to be the late finish of activity A, the predecessor. Use the same equation. 5 as a late finish minus 3 months as a duration, and the late start of activity A will be 2. What we have understood from this process, we have discovered that some of these activities, they have a change between the late start and the early start, and the late finish and the early finish of these activities. One thing is remaining in order to complete our network diagram is to calculate the float. We can start calculating the float from anywhere on the network diagram. Why? Because the equation that we have, it says that the slack or the float equals the late start minus the early start, or the late finish minus the early finish. Since we have the early start and early finish of every activity, we can start from any activity. Let's take, for example, activity B. What's going to be the float of activity B? The float of activity B will be 26, which is the late start, minus 16, which is the early start, and that's going to be 10. And if you apply the same, you will say that the late start is 22 minus the early start, and that's 12, and the answer again will be 10. Then activity B, it has a float of 10. Let's, for example, take activity A. Activity A, it has a late finish of 5 and early finish of 3. If we subtract these two from each other, we will see that 5 minus 3 is equal to. If you do the same for the late start and the early start, 2 minus 0, and that's going to be 2, then activity A has a float of 2. Activity F. Activity F, it has a late finish of 13 and early finish of 12. 13 minus 12, and that's going to be 1. Again, F, the late start for activity F is 5, minus the early start of activity F, that's 4. 5 minus 4, and that will equal 1. Then activity F has a float of 1. We have noticed that activity A, it has a float of 2, activity F, it has a float of 1, and activity B has a float of 10. Let's see about the other activities. Activity D. Activity D, it has a early start of 0 and late start of 0, and 0 minus 0, that's 0. And late finish is 4, and the early finish is 4. 4 minus 4, it means that equals to 0. It means that this activity has a float of 0. Activity E, late finish 13, early finish 13. 13 minus 13, that's 0. Late start as 4, early start is 4, and that's again 0. And if you do the same for activity G, you will find 17 minus 17 and 13 minus 13, and that's equal 0. 19 minus 19 and 17 minus 17, that's 0 for activity H. And activity C, you will find that the late finish is 26 minus 26, that's going to be 0, and 19 minus 19, again that will be 0. For explaining further, let's first of all know what does it mean float. Float, it means a flexibility in the duration or in the activity duration itself. For example, if we take activity A can be completed as early as 3 months or can be completed as late as 5 months. It means that this activity has a float, a flexibility in its duration of, or the accomplishment date of that activity of 2 months. Activity F, we can finish it as early as 12 months or as late as 13 months. It means it have a 1 month flexibility in its accomplishment date. Same for activity B. If we look into activity B, we can finish it as late as 26 months or we can finish it as early as 16 months. It means it has a 10 months of flexibility in its accomplishment date. But if you look into activity D and E and G and H and C, you will see that they have a 0 float. Why? Because we can finish them as early as 4 and as late as 4. That's for activity D, and that applies on all the other activities. It means that these activities doesn't have a flexibility. In another word, we cannot delay these activities more than 0. We cannot delay these activities more than 0. And this means that these activities fall on the critical path. Since activity D, E, G, H, C, they have a float of 0, we call these the activities on the critical path. Why? Because we cannot delay them a single month or a single day because we have a float of 0. Activity A, activity F, activity B, they are not a critical path activities. So from doing the backward and the forward, I'm calculating the early starts and the early finishes and the late start and the late finishes, and then I'll be able to determine what's going to be the float for every activity. And if I know that that activity has a float of 0, then that activity is on my critical path. What does it mean, critical path? It means the activities that I cannot delay in my project, otherwise the project will be delayed. Finally, this is how your network diagram will look like. We have determined that my critical path is D, E, G, H, and C, and the duration is 26 months for that path, and that's the critical path for my project. And how we will determine the critical path? The critical path is the longest path on the network diagram. It is the longest path on the network diagram. And it is the shortest period I can finish the project with. I cannot finish it less than 26. All the activities, definitely I'm talking about the all activities. If you think that, for example, 16 is a critical path for you, if you compare 16, B and G, you will see that G is not yet completed because it requires 17 months to be finished. So it is going to be the shortest period for my project to be completed, all the activities from start to end, and it is the longest path on the network diagram. Now what I need you to do is to pause the video and start completing your network diagram the way that we have explained it, and you will see the answer at the end of this video. This is the answer for the question that we have asked earlier of completing the network diagram with the table that we have provided you earlier. Hopefully that you get the answer right. If you had any of the wrong answers, just compare it to the answer over here and see what you have done wrong. If you still have a problem with that, please contact us and we'll see if we can help you, and we will try to help you. Thank you.
Network diagram, it's a very important document in the project, and using the precedence diagramming tool will help the project manager to develop his network diagram, and then the project manager will be able to know how long the project will take as a complete duration, and what are the activities that they are on the critical path, and what are the activities that has a float. For those who are attending the PMP exam, during our training we will give you the tip how to quickly calculate the critical path and determining what is the float of the activities. And because you don't have that much time in order to draw the forward path and the backward path, then calculating the early start, early finishes, and then determining the float, that's going to be a very long process during the exam, and you don't have that much time. This is the end of our video. Remember, subscribe, like, as well as click the notification button to receive every new video we have. Follow the links below this video in order to know how we can help you in project management.